Good morning, ladies and gentlemen. So, welcome to our first flip video for our Algebra 2 classes here. My name is Mr. Ortiz, and I'm going to be experimenting with making videos for us this year where that content is available for you guys online. And in class, I want to give you guys more time to be able to work and focus on what you need, and to be able to focus myself on your weaknesses and help you get stronger. So, we start out today with checking solutions. What is a 3x3 system? We've seen some examples, and here's one down here. So it could be three equations with three variables. And so one thing that we want to keep in mind, as we check for solutions, we're going to substitute for the x, y, and z variables in each equation. Keep in mind that an ordered triple is represented by x, comma y, comma z. So this is a three-dimensional point. A point in three-dimensional space. To be a solution to a system of equations, as we substitute, all the equations must be true. So it means if even one is false, then it's not a solution to the system, because system implies that all three are working together. So our first example, so we're given this ordered triple 4, -1, -5. And so to help us remember, this is our x, y, and z values. And our purpose now is to take these values and to substitute. And so before I get started, I'll give you a little color coding. So we're going to take this x value and replace each x with that value. So we're also going to take the y value and substitute that for each y value here. So there could be sign changes, I may have to multiply, and then we'll combine and add or subtract the numbers. And so lastly, we have z. Okay, so let's go ahead and let's start on the first substitution. So we'll take the first equation. We're going to replace x with 4, so we get 2. Parentheses, 4. And I use parentheses here to show that the 2 is multiplying with the x. We have subtraction, and then the y value of -1. And plus, and the z value of -5. And we want to know, does this equal 4? Okay, so let's test this out. So some of the things to talk about is a negative times a negative, or when I go subtract a negative number, negative times negative is positive, so it turns this into addition. And positive times negative is negative, so it turns that into subtraction. So what we get is 2 times 4 is 8, minus -1 is like adding 1, and plus -5 is like subtracting 5. And does this equal 4? So 8 plus 1 is 9, minus 5 definitely equals 4. So we can stop here because we can see it, and we'll put a little check. So one equation works. What does that mean? We have to keep going. We have to check the others. So we'll take the next equation. Do you have to take them in order from top to bottom? No. You can start with whichever one that you would like to. So now x is 4 again. Plus 3 times, and the y is -1. Yet again, they're multiplying, so I use parentheses. Minus 2 times z, which is -5. And does this equal 11? Okay. So 4 is 4, so we'll bring it on down. 3 times -1. A positive times a negative is a negative, so now it's like we're subtracting 3. And -2 times -5 is a positive 10. Negative times negative is positive. And does this equal 11? Well, 4 minus 3 is 1. And 1 plus 10 is, in fact, 11. We're looking good so far. Alright, so the last one we'll test. So far, it is a solution. If this one's false, remember, if any one is false, it is no longer a solution to the system. So now we have negative and we substitute 4 for x, minus 2, and the y value is negative 1, and they're multiplying, so I use parentheses, minus 4 times negative 5, and does that equal 13? Okay, so the negative in front of that 4, so now we have a negative 4. Negative 2 times negative 1 is a positive 2. And negative 4 times negative 5 is a positive 20. And does this equal 13? So we can already start to see that this doesn't work out. So we get negative 2 here, plus 20, and does that equal 13? And definitely it doesn't. So what we start to get is positive 18 equals 13. This is not a true statement. And so we can conclude at the end that the ordered pair 4, negative 1, negative 5 is not a solution to the system. Alright, so what I'd like you to do is to try to go and do example number 2 on your own. And as you come into class, I'd like to check your work there. Before you come to class, however, if you would like to know, hey, did I do it correctly, at the start of my next video, I'll go ahead and I'll show you guys what the completed problem looks like.